Hi, Accelerated Algebra. It is an excellent idea to take a few notes while you watch this video. You can always pause for that. So remember, when we're solving absolute value equations, we want to isolate that absolute value. So we want this to be all by itself on one side. That's kind of our first goal. So if I add 1 to both sides and then divide by 2, then remember what this means. This means that when I take the absolute value of x plus 5, it equals 5. So that thing inside the absolute value bars must either be equal to 5 or negative 5. So I've got two solutions here, 0 and negative 10. And I can plug those back in. Okay, let's do something similar for an inequality. There are two methods for doing this. I'm going to show you the first way that I normally do it, and then I'll show you the way that DeltaMath usually does this. So we'll solve it just like a regular inequality until we get to this point where the absolute value is isolated. So let's think about what this means in terms of distance. So this, if we write this in terms of distance, remember this is saying the distance between x and negative 5, because this is the same as x minus negative 5. The distance between x and negative 5 is less than 5, which means that if I draw this on a number line, here's negative 5. The distance between x and 5 is less than 5. So if it were 5 to this way, that'd be a 0. If it were 5 to this way, that'd be a negative 10. And if the distance has to be less than 5, we have to have this area in here. Now, DeltaMath is going to have you write this as an inequality. So you're going to write it as negative 10 is less than x is less than 0. And that says x is in between those two numbers. Okay, here's another way to do it, which can be really useful and probably less prone to mistakes, so it's worth noting. The first step on this one is you change everything into an equation, and you just solve the equation. Now, we already did that in the previous part of the video, and we got x equals negative 10 and x equals 0. So I'm not going to do it again. And then you draw that on a number line. And then you plug in values in each section of this little graph to determine which section makes this true. Okay, so let's plug in something over here. So maybe negative 20. If I put negative 20 into this equation, okay, so after you have this number line, you plug in numbers that are in different parts of the number line. So here I'm going to test negative 20. That's my first test point. It's on this side of the negative 10. I'm going to take the original inequality and plug in my test point. So I've plugged in negative 20. That's false. Actually, everything on this section of the graph is going to end up being false. Now let's plug in something, test something over here. That's also false. All right, now let's plug in something here in the middle, maybe like negative 1. That seems pretty easy. That's true. So that tells me how this should be shaded, or how the graph should be drawn in. We want to include everything that's in the true region, and then since it's just a less than in our inequality, we have two open circles. And we're still going to write it at the same way that we wrote it before. Negative 10 is less than x is less than 0. Okay, now let's do another inequality where we do it in both ways just to get the hang of it. First, keep it as an inequality way. So this says the distance between x and 2 is greater than or equal to 3. So if we put 2 on the number line, and then we go 3 this way, that's 5, and we go 3 this way, that's negative 1. We've got to be further away from 2 than 3, or exactly 3 from 2. So that's going to be this picture like this. And if I write that, I have to write this as two separate pieces because there are two separate parts of the graph. So the way I'm going to write it is x is less than or equal to negative 1, or x is greater than or equal to 5. And I need both of those pieces in my answer. And you'll see on DeltaMath it has a little or symbol for you. So let's do it the other way, where we take this and we change it into an equation first. So of course this has the two solutions, 5 and negative 1. So I'm going to draw my number line, put 5 and negative 1 on there, and I'm going to write down the original inequality, and then use a test point in each region to figure out which region is the one where all the solutions are. So let me just try the one in the middle first. As a test point, I'll plug in 0. And I can do that pretty much in my head and see that it's not going to be greater than or equal to 4. So that's false. Let me plug in something bigger over here, say like 10. I can see in my head that that's going to be true. And let me plug in something over here, say maybe negative 10. And I can also see that that's going to make the inequality true. So when I go to draw the picture, I know that 5 is going to work because that's the equal case. I know that -1 is going to work because that's the equal case. And then the pieces where it says true, those are included. And so, again, you're going to write it the same way. X is less than or equal to -1, or X is greater than or equal to 5. Okay, and now if you get stuck on any of these, you should be able to watch the video also within DeltaMath.